Hey students, welcome back. This is 7.6. This is pH and POH. You will definitely want a scientific calculator handy, so please, please, please get that ready because we're going to use that as soon as we get some vocab out of the way. So let's jump in with some vocab. So we have hydronium ion. So this hydronium ion is a measure of the acidity of a substance. So we're talking about how much acid does it have there. So we're talking about the acidity of a substance. So what do we got there for acidity? All right. Then we've got our hydroxide ion, which is just the opposite, obviously. So hydronium was the measure of the acidity. This one is our measure of the base. All right. So we're going to talk about measure of the base, how basic we have. All right. So then these numbers are very, very small. We're talking like times 10 to the negative 5th through 10 to the negative 14th. So they're really, really small numbers, right? And makes them not very fun to work with. So what they did was they came up with our pH scale. And our pH scale shows us the concentration of the hydronium ion concentration. So shows us our concentration of our hydronium ions, and I should probably do a little erasing there. Sorry, because officially when we put those brackets on, that's hydronium ions, or concentration. So it shows us our concentration of hydronium ions. All right. Then we have POH. That's going to show us our concentration of our hydroxide ions. All right, so what we're doing is pH and POH make it easier to deal with, all right? And that's why we use them there, okay? So some other information that we've got there is an acid has a pH of less than 7, all right? And a base has a pH greater than 7. I don't actually like the greater than and less than signs, so sorry if they never made sense to me. I apologize. All right. Now we need some formulas. So some formulas that we're going to use here. And these are very important formulas, and they're the ones that we're going to use a lot. So please make sure you get these correctly. So our first formula is H3O concentration times our hydroxide ion concentration is equal to 1 times 10 to the negative 14th. So we're going to be using our EE button on that. All right. Our next formula, pH plus POH is equal to 14. All right. Our next formula for today is pH is equal to the negative log of our hydronium ion concentration. And our final one for today is POH is equal to the negative log of our hydroxide ion concentration. So these four formulas are very, very important. We're going to use those a lot. If you're not in class, you should get a Post-it from me so we can write these on there. All right, but these are the ones we're going to use, all right, quite frequently for this practice. So let's kind of keep those in our rear view, if you will, and see if we can't figure out how to use these. So if we check out that very first problem, it says, if we have a pH of 3.45, what is our POH? So the only formula that has both pH and POH in it is this one right here. So we're going to use that formula. I'm going to raise this up just a little bit. pH plus POH is equal to 14, and we're just going to plug in 3.45 for our pH. 3.45 plus POH is equal to 14. Now we're going to go ahead and solve, subtract 3.45 from each side, subtract 3.45 from each side, and our POH is going to be equal to 10.55. There is no label on pH and POH, so just rock it just like that. So hopefully that one makes sense to you. Awesome. Let's look at the next example. This time we're looking for pH if we have our hydronium ion concentration. So we're looking for pH and we have our hydronium ion concentration. So if we look back at our formulas, the one that covers that, I'm going to go to purple here, is this one right here, right? This one gives us pH and we have hydronium ion concentration. So we're going to use that formula. Blow this up just a little bit. pH is equal to our negative log of our hydronium ion concentration. Okay? So now we're going to go ahead and plug that in right there. So it's going to look like negative log of 2.22 times 10 to the negative second. All right, now typing this into our calculator. If you're using a calculator, an actual calculator, what you're going to type in is you're going to type in, most likely, you're going to hit negative and then the log button. Then this little parentheses will come up and you're going to put 2.22. And remember, for exponents, we use that capital EE, right, for most of our calculators. So E, and then we're going to say negative 14 and then the equal sign. All right, that's a calculator. If you're going to use an iPad, iPhone, whatever there, this one you have to kind of do it in reverse. So you're going to hit 2.22, then your EE button. Remember, that's capital EE, right? And then negative 2. And for some reason, it wants you to hit the equal sign. All right. And then you're going to hit the log button. Okay. And you're going to have a negative sign on that. When you type this in, you're going to get like negative. Let me type it in myself here. Negative log 2.22, negative 2. All right. You're going to get negative 1.6536, right? We're still going to only keep 2 decimals, but on this one, you just wipe off the negative sign and make it 1.65. So your overall answer should be 1.65, and that should work for both of them, all right? You should get the same answer for both of these no matter how you typed it in. So please make sure you get that correctly. If not, come ask me for help, and I'll make sure and get you set up. Okay? Awesome. So now we want to, looks like my number didn't get plugged in there, but that's cool. Let's just make one up. So let's go 1.57 times 10 to the, how about negative fourth? So we're going to start with 1.57 times 10 to the negative fourth hydronium or hydroxide ion, and we've got to take that to hydronium, to pH, to POH, and roll from there. All right, so let's start this off, and let's go ahead and start by finding this first one, the hydronium ion concentration first, and we're going to use the formula H3O times our concentration of OH minus is equal to 1 times 10 to the negative 14th. And that should make sense because, well, we have hydroxide and we're looking for hydronium, so we're just going to plug that in and solve. So hydronium ion concentration times the 1.57 times 10 to the negative 4th is equal to 1 times 10 to the negative 14th. All right. Now we want to isolate our hydronium ion concentration, so I'm going to divide each side by that 1.57 times 10 to the negative 4th. All right, 1.57 times 10 to the negative 4th. And we're going to get hydronium ion concentration here. Now remember, when we type this in, we'll use that bottom box for how to type it in our calculator. But our calculator should all be the same regardless of iPad or iPhone or calculator. So we're going to hit 1 EE, and remember it's like a capital E, right, that we're looking for. And then we're going to say negative 14 divided by 1.57 E negative 4. All right, that's how we're going to type it in our calculator. So please do that now. Negative 4. And so we should get, when you type this in, the answer you should get is 6.37 times 10 to the negative 11th. Please make sure you got that. All right, that's what you should get there. Okay? Sorry about my dogs. Somebody is apparently walking around in the backyard. Okay, so everybody's got that. Hopefully that's good. All right, so we have our hydronium, we have our hydroxide. Now we can find pH and POH from there. So let's go to pH. And our pH is going to be like that one we just solved up above here, right? So we've got pH, all right? pH is equal to the negative log of our hydronium ion concentration. All right, so we're going to take negative log of that 6.37, this is the one we just found, times 10 to the negative 11th. All right, plug that baby in. If we're going to plug it in like we did before, we're going to say negative log and then 6.37 e negative 11. Or if we're on the iPad, we're going to say 6.37 e negative 11, hit equals, then the log button, and take off the negative sign. All right, so let's go ahead and plug that baby in. Negative log of that 6.37 times 10 to the negative 11. And we should come up with, going back to the right color, 10.20 with 2 decimals there. And remember, pH and POH have no label, just there. Okay, awesome. We should get 10.20. Okay, let's move on, and let's now check POH. All right, and let's do, we haven't done orange yet. All right, so now POH, we can do this a couple of different ways. We can either say POH is equal to 14 minus pH, like we did a little bit earlier. I just rearranged it, right? Remember the formula we started with? pH plus POH equals 14, right? I just rearranged it. No stress. Please don't let that stress you out. All right. So then if we just do that, we can just take 14 minus our 10.20 and we'll have our answer. All right. That would be 3.80. All right. That would be one way we could do it. We could also take, just as an aside, another way we could have done this is taking POH is equal to the negative log of our hydroxide ion concentration. We could have done the same thing there where we had negative log of 1.57 times 10 to the negative 4th. And we should have come up with the same answer. And let's just go ahead and see what we get there. Negative log of 1.57 times 10 to the negative 4th. And we should get 3.80, which is pretty awesome because that's what we should have gotten. Awesome. See how we got that there? We had 2 ways. Now our last answer is it an acid or a base? And how we decide that is we look back to here, is it an acid or a base? If our pH is above 7, that means we have a base, so we would record this as a base. And we are done. Okay, I hope that helps. See you next time.